Okay, we now have phase 1, the mechanics of our game, in place. It is time for phase 2. Now we get to focus on turning this into a playable game, where we could actually start the game and lose lives as the target strikes the ground. And finally, the game will end once we run out of lives. So Logan, let's take a look at our implementation plan. So here in gameplay, the very first thing we've got is create 2 new objects, a title screen and lives display.
Okay. Let's jump over to the designer and bring up the toolbox. From the toolbox, let me scroll back up to picture box, because of course the lives display and the title screen are both going to be picture boxes. So we'll create 1 picture box and then just create out 2 picture boxes.
Okay.
And now we're done with the toolbox. Now let's make this one, let's have this one be our lives display. So I want to set up a few properties manually here. Of course, I also want to set up the name, so I'll begin with that. This is going to be our lives display object. Alright. Now I'm also going to set the dimensions by hand as well. I want this to be an image that's 48 in width by 16 in height, because basically what it boils down to is what I've done for lives display is I've taken that triangular player graphic, I've shrunk it down by 2, so it's only 16 by 16 now.
Okay.
And I've made the graphic so that there's 3 of them. That represents our 3 lives.
Okay.
The idea here is that we have this graphic. If it's at its full width, it'll show all 3 lives because it's 48 across. As a matter of fact, let me get that.
Let me just go ahead and type it in real quick.
So 48 by 16. The idea is that in this width we hold 3 lives, and we can just shorten this image to start cutting off lives as we lose them.
Yeah, that's good enough of a description right there, Logan.
All right. And since I'm doing the dimensional setup on this manually, I'm also going to move it into place. Though, instead of 8 by 8 or 16 or whatever that is, I actually want that to be closer to the edge of the screen, so I'm going to punch in 4 by 4 for our location offset. So that should take care of lives display. It's at the correct dimensions and correct location. Now let's take a look at the title screen. As a matter of fact, we need to name this. So this is going to be our title screen, and I'm not going to worry about positioning this because the idea is that this is a full screen overlay, almost like a splash screen just inside of the screen area. And if I were to align this by hand here, well, for one, the screen isn't 640 by 480 at this point.
That's correct.
So I'm going to do the alignment of the title screen in code.
Okay.
So let's jump back over to code, and let's see. I guess we could get the visual setup. Let's finish off our object setup before we move on. So let's focus on the lives display, just because we threw that down first. We'll take our lives display picture box. We'll have it load in a graphic, and one of the other graphics we had in that folder was a lives display PNG file. And I'm going to go ahead and run just to make sure that that's right and loaded in.
And let's check to see what the name actually is.
I was almost wondering that. Let me jump back to Canon, into our bin folder, into debug, where we had placed all of our images, and that was lives instead of lives display.
Okay.
So
I know you did that on purpose. That's all good. Okay.
And
there we go. Upper left-hand corner. There's our lives. Very good.
Alright, now we need to get the title screen in place. So we need to take our title screen, and I guess first off we could load the graphic that it needs. So let's load in our title. I think this was the one that had the underscore. Title screen.png. And just out of habit, let's check. There we have our title screen, so that should be good. Okay. Now, if we load, it's probably too small to see the text because the title screen itself is gray, just like the form. The text is in the center of it. So if we load, we probably won't see any difference, except for there should be. There we go. You can see the projectile. Well, it'll be hard to see on 10 frames a second, but it just disappeared for a second underneath it.
Exactly.
Let's go ahead and align the title screen up, though. Let's take the title screen's top and left, or let's say left and top, and set those to 0. Title screen top, and we'll set this to 0 as well. Now we need to set the width and height of the title screen to the overall screen width. So we can take title screen dot width, set that to screen width, and title screen's height set to our screen height. And now if we run, we probably have, there we go, click to begin.
Okay.
Though, of course, we haven't put any of the functionality in, so we're stuck at this title screen.
And we're seeing that as opposed to the other graphics because it was created last, so it's actually on top of the other ones.
That's right. So that has our objects.
All right, so we've created 2 new objects, title screen and live display. Looking back over at the implementation plan, the next thing was to go ahead and create some new variables, such as is game running, lives, level, and I think this is also a great place to throw in another little constant that I'll see here in just a second.
Okay, let's get the variables plugged in. So let's see, we'll jump in right before the random, and let's begin with a boolean for is game running.
Okay.
So we'll have bool is game running, and we'll set that to false by default. I know it would probably be automatically initialized, but that makes it clear. And now we need our integer
for lives.
So I have an integer for lives and an integer for level.
You want to go ahead and initialize both of those?
Yeah, as a matter of fact, this might not be a bad place for a few more constants. If we had, let's say, a constant for the default number or the starting number of lives.
Okay.
So let me jump back up to our constant section and put in constant integer for starting lives.
I like it. Except let's go ahead and put something in it.
Yeah, we need to have this be, let's set this to 3, that way it matches our graphic where we begin with 3 lives.
Okay.
And then when we make our lives variable, as a matter of fact, we don't need to initialize it here. We can do that in begin game. Because if we initialize it, that only works for when we first run. Since we want to be able to begin the game again, we'll need to reset it there anyway.
Okay.
So we'll use the constant starting lives. Now we have one other thing we need to worry about, and that is the
tile width, basically.
Yeah, we have that graphic, as a matter of fact, if I run just for a visual aid. And I'm going to cheat for a second. I'm going to bring this to the front. So if we look at the graphic we have for our lives, you can look at each of these as a tile. So if we took some of the width away, as a matter of fact, let me go ahead and show that in the designer just to make it one step more clear. If we took our lives display graphic and took its size and reduced its width down from 48
to 32, so we've subtracted 16 away. Now if Logan runs it, look at that. We have 2 lives. Whoa.
Right, since each of these tiles are 16 pixels in width, if we subtract 16, then we'll remove 1 tile.
So go ahead and subtract 16 one more time, so we've got 16 left, and I'll see that at this point it looks like we have only 1 life. Ta-da! All right, very cool. So what we need to do is just hold that number that we keep subtracting away. It's basically what we're calling a tile width that we can use later on.
Right, we just need some convenient place to put that so we can use it later. So we can say subtract an entire tile width.
Okay.
And I'm also going to set our lives display black to 48 now for its beginning size.
So a constant called something like lives tile width.
Okay. So I'll have a constant. This will be an integer called lives tile width.
And
we'll
it'll
set
be
that
16.
to 16.
And again, us as the designer going through and actually creating the graphic, that's why it's not that it's a magic number, that's why we know what it is. Okay? Cool.
All right.
So now that we've got some variables in place, the next thing we're going to do is go ahead and skeleton in the rest of our methods. Begin game, end game, kill player, and kill target.
Okay. And all of these are gameplay methods, so I'm going to scroll down to the gameplay methods section in code, and we'll lay these in, beginning with the begin game method.
Okay.
So this will be a private void begin game. Then we have private void end game. Then we have our kill player and kill target. So we have private void kill player.
And private void kill target.
Private void kill target.
All right, according to our implementation plan, that's all we needed to do for skeletoning the rest of the methods. So now, the next thing that we had written in the implementation plan was allow the player to start the game.
Okay. So in order to do that, since if we look at the game now, we have a title screen that says click to begin. That's what we need to allow. We need to allow a click. And where are we checking for clicks? Well, we've got our event handlers, and one of those being a mouse. Mouse down here. This calls upon fire. So let's take a look at fire. We could take fire.
Well, the whole idea, well, go ahead. What do you got on your mind?
I'm actually thinking of changing this up just a little bit. It might make sense to do the check from within the mouse down.
Okay.
So we do a check from here. So we say if the game is running, begin, or if the game is not beginning yet, then begin it. If it is currently running, then we need to fire.
Okay.
So let's do our check where we say if is game running. If the game is running, then we need to fire. Solely fire projectile and that block. And now we need to do an else. So if the game is not running and we click, that means we need to begin the game. So we'll call upon begin game, and that should get us started.
Okay.
Though, of course, begin game doesn't have any code in it yet.
Right.
So in order to continue on with this,
if you don't mind me just asking you a question, hope you guys don't mind. You said you were thinking about changing this. Isn't this how we had originally planned it?
It is. I might have just been confused in what I was thinking for a
second.
second.
Oh, okay. Because you really confused me for a second, because this is exactly what I had in mind.
I think my mind went back through the way I had originally put this together.
Ah, okay.
And so I just spent a half a second coming up with my original plan.
Well, this right here is following our spec perfectly, so that's what I'm looking for. All right, beautiful. So now we can go ahead and focus on begin game.
Okay. Let's turn our attention now to the game plan methods where we have begin game.
Or obviously, the very first thing we're going to want to do is set that is game running variable to true.
And to remember that we've started the game.
Which means the next time you hit the fire button, it's not going to be false. The game is running, so now we can fire.
All right. Next, we need to reset our lives, because if the player had already played through a game, lives will probably have been exhausted.
Exactly.
So when we begin a new game, we need to give the player 3 new lives. And not just 3. We don't want to hard code in 3. We've got our convenient constant defined up here for our starting lives, so we always know what we need to reset lives to when we begin the game.
That's right.
So let's set our lives to be equal to our starting lives constant value.
Okay.
Now, we have level. Level just tracks how far we've progressed, basically how many times we've killed the target.
Right.
And we want that to begin at 1.
At 1, okay.
So we'll set level to 1. All right, and that has a lot of our gameplay stuff together. Now we need to call upon a few methods and get things cleaned up if necessary.
Okay.
This means doing things like resetting the projectile target and so on. So let's make calls to reset projectile and reset target. All right?
Okay.
Now, since we're beginning the game, we need to take down the title screen.
Giant title screen, and we need to hide it.
So we can take our title screen and simply call its hide method, and that will hide it.
Okay.
And also, since the mouse kind of visually interferes with the look of the game,
sure,
let's hide the mouse whenever the game is running.
Sounds good.
So we can access the cursor and tell it to hide as well, like so.
Okay, cool.
Now, I believe, if we were to test now, let's see how much of this is working. Let's build the game, click to begin, and oh, I see what's happening. We get nothing because this title screen
is getting that mouse down.
Is catching a mouse down event. So let's go back.
I would go ahead and grab that and bring it to the front just so that it's over your lives.
Right. Let's grab our title screen. Let's first bring it to the front.
Okay, so that puts lives behind it. Then let's go ahead and take enabled and turn it to false, because again, it's what's getting that mouse down as opposed to the form. Okay.
Right. So let's try now. Now, okay, we've got our lives hidden. If we click,
and we begin the game.
The game begins. And notice that we reset upon begin, so we no longer have the target that starts in the middle of the screen and slowly wanders off screen.
That's right.
Everything begins at the proper state.
I'm loving it. It's starting to look good.
And you can see the cursor is hidden now.
Okay.
Thinking about it, I don't know if that'll show or how that'll show on the capture. They might still see the cursor.
Oh, that's a good point, guys.
But just take for granted on our end, the cursor is indeed hidden.
That's right. Okay, so let's look back over here at the implementation plan. So the next thing we had was track our lives and end the game when we run out of lives.
Okay. Now, to track the lives, we're going to need to change the way some of our thinking works here. Because right now, we've made ourselves a kill target method, but we're not using it yet. When we hit the target... Wait, what was it? I'm confused. You said you would want us to check lives, not
well, no, I just said track lives.
I got you.
Track lives and
I
end
was
the game.
looking at target. That means we need to look at player.
Okay.
Inside of player,
That's right.
All right. So, all right, to track lives, we need to say every time the player dies, we take a life away.
Okay.
So let's code in the kill player.
Okay.
So inside of kill player, the first thing we need to do is take our lives value and decrement it by 1.
Okay.
And let's see, there needs to be...
So now we're going to need to make a couple little changes right here. Because we've got reset target and reset projectile being tied into the collision areas right now.
Right, as a matter of fact, if we take a look at collision...
We can make the code a little bit more readable, if you will, if we change the logic around just a tad. So if we have a ground collision, what do we really want to do? We want to kill the player, because that's what's happening right here. So we're just going to change that to kill player. Now back up in kill player, we'll take care of doing our reset.
Okay. So from here we'll reset our...
Well, we're going to need to do both. Reset target and reset projectile.
Alright.
Okay. And the one that you just took a look at, let's go back down to the collision area real quick, just to make sure everything's nice and clear. So back down to, alright, so here we are with collision. So check air collision. Alright, and the one actually above is the one we addressed just a second ago.
Right.
So here we had a ground collision, and that took care of killing our player. Okay?
So I guess
in this particular case, do we want to... Well, no, we do want to kill player. So yeah, that works. Go ahead. While we're here, you want to go ahead and redo this?
Right, we might as well take a look at check air collision. In the case of air collision, that means the projectile has collided with the target. So we could take out reset target and projectile from here and instead change this to kill target.
Okay.
That means since we remove those, we should also go back up to kill target itself and place the reset target, reset projectile inside of here. So reset target and reset projectile.
And after you do that, change your logic around just a tad. Check this out. And this is okay at the moment. We've got when the player gets killed, the player, do we really want to reset the projectile? Because it can continue just moving on off screen. So as soon as you respawn, in essence...
That's true. That would make it look like the projectile is in fact independent of you. So I don't have a problem with that.
I think it just look a little better.
All right. So what have we got so far? We've got a kill player where we decrement lives and reset the target. And we've got a kill target where we reset both the target and the projectile.
Okay, so we're now tracking our lives. Now we need to, well, basically check when we run out of lives, the game's over.
Right. So I guess that would be back in kill player. After we've run out of lives, we then need to turn around and do a check.
Right, because if we basically have no lives left...
So if we've run out of lives, or if lives is equal to 0...
Right, then we're going to end the game. Beautiful.
And we'll make a call to end game.
Now, I really hope, at this point, before we progress much further, because we have indeed changed the logic around just a little bit, that everybody understands what we did. If we come back down here to our collision methods, it just makes more sense. We've had a ground collision, so we need to kill the player. And then we can put all of our cleanup stuff inside kill player. And by having this calling kill player, we can also take care of saying, well, does the game need to be over? We decremented our lives, all that stuff. So it's a great place to package everything. And again, for readability, it just makes a lot of sense. Earlier, we needed to do the reset in here for the simple fact that we were just getting the mechanics into place. And the same thing is going to apply down here with our check for an air collision. Well, if we have an air collision, we're going to kill the target now. So with kill target, then we're simply going to worry about resetting our projectile and our target. So I just wanted to make sure that we went back over that so that everything is nice and clear with why we've got it now calling kill player and kill target. It just makes it a little easier to read, and it's a very convenient place for us to come in here and package specific code that is related to kill the player or kill the target, okay? As opposed to having that wrapped inside something called check for collision. So now we've taken functionality and broke it out into its own little module, if you will, in a way that makes sense.
Right. And just looking at this for another thing to clean up for readability, I'm actually going to move the lives decrement to right before the check. Because that way we keep everything relevant to lives all together, all in the same place.
Okay, sounds good. All right, so yeah, we're progressing along nicely here. Where's my implementation spec? So I guess we can check this real quick. Go ahead and run out of lives. Well, actually, endgame's not been coded yet. You want to code in endgame?
Yeah, we can go ahead and do that.
Okay.
Then we can check and make sure that our endgame or that our lives tracking isn't currently working.
Okay.
So inside of endgame, some things we need to do. First, we need to go through and we're going to need to...
First, the is game running needs to be marked as false because it's no longer running.
So we'll set isGameRunning to false. Now we need to bring our title screen back up, because of course we don't really have an actual ending graphic.
That's right.
So we'll just bring the title screen back up. So we'll have our title screen, we'll tell it to show, so we'll call it show method. And finally we need to bring our cursor back in case the user wants to exit instead, or at least see where they're clicking before they click to begin.
Okay.
So we'll bring back our cursor with a cursor, or call to cursor dot show.
All right, now we can test it out.
All right, we begin, and I'm not even going to bother shooting.
1 life, 2 life, 3 life. Ooh, click to begin, and our cursor is back. All right. So now we need to fix that display number of lives because it's just staying at 3 the entire time. We need to start decrementing, or at least give the illusion of it being decremented.
Okay. And that's actually going to call for a new method.
Okay.
We're going to need to put in a method for displaying the lives. So we'll make a private void display lives.
The implementation plan still holds up because obviously the implementation plan does not give you the final code. So in the create skeletal methods, that's one we left out, but we picked it up a few steps later where we said handle displaying the number of lives.
Right.
I thought that was kind of funny.
So it would make sense to have something like a display lives method.
Right.
All right. So inside of display lives, now we need to address the width of that display, or the lives display picture box, and set it up so that it uses our lives tile width. If you remember back up in the constants, we have a lives tile width.
Okay.
So really this is actually very easy. We just take the width, or we set the width of our tiles box by basically how many lives we have left.
Okay.
Or rather, we take our lives display dot width and set that to the number of lives we currently have remaining times the lives tile width.
Yep.
All right.
So now lives is changing on us. 3, 2, 1. So if we only have 1 life, the tile width is set to 16. How much of the lives display graphic are we going to show? Only 16 pixels, starting from 0 over to 16, which will show us 1 ship. If lives was 2, 2 times the tile width being 16 gives us what? 32. 32 pixels, starting at 0, moving over, shows us 2 ships. So hopefully you guys see how that works.
All right. So now we need to call upon display lives in relevant sections. And that would be during things like when we begin the game to make sure that we show the 3 lives. As a matter of fact, let me jump up to begin game to show that. We have our lives set here. So that means after we set that, we need to also display our lives. So we see that our lives gets whatever this new starting lives value is.
Okay, part of a little bit of cleanup action that's going on there.
Now, the other place we need to update the lives display is whenever we get killed.
Killed.
So we need to jump down to kill player, and after we mess around with lives, we need to say display lives. As a matter of fact, let me jump in between the check.
Yeah, right after we subtract lives away, let's go ahead and update what we see before we do the check.
So we'll display our lives, and then we'll do our check.
All right, it's as simple as that. So the begin game and the kill player, that's the 2 areas we're going to put in display lives. Let's see if it's working.
Okay, we begin.
All right, so, ooh, perfect.
Right. And then to make sure that begin game is setting everything back up, we begin it over with 3 lives, and the display works properly.
Fantastic. Now there's one thing that was left off our implementation plan, Logan, but it was in the requirement. So we're verifying that this meets our requirement. Well, it doesn't meet our requirement because it needs to become a little bit more challenging. Each time you hit the target, it needs to be a little bit more difficult, meaning that the target needs to move a little faster.
Right, and we made a level variable to track that. We've got our level, but we're not doing anything with it yet. So let's increment our level every time we kill the target. Like you said, every time we hit the target, the game gets a little bit harder.
Right.
So we're going to kill target, and after we reset our, matter of fact, in this case specifically, before we reset our target, we need to increment our level. So we'll take level and increment it. And this is very important to do before reset target, because reset target is going to need to take level into account when it decides what the target velocity y is going to be.
Precisely.
So let's jump down now to reset target. Let's take a look at velocity y. We know we've got our base speed, but let's add on to that whatever is in level. Now, I can do a quick test. I don't want to leave it at level. I actually wanted to increment a little bit more slowly than 1 every time. So let's just take a look at what this would give. If I kill the target a few times, you can see that it's getting faster.
Faster and faster.
Very quickly, and it quickly gets almost uncontrollable. So I'd rather not have the game become uncontrollable that quickly. Instead, what we'll do is we'll increment it by level divided by 3. Now, of course, because this is integer division, that means there is the possibility that level,
it's not the possibility. It will happen. There will be some levels where you're going to advance, but the speed's not going to increase.
Right. We keep tracking that in level, but for one level increase, we might not see that reflected back in target velocity y. We will once level gets high enough that level divided by 3 is an entire integer higher.
That's right. But in the grand scheme of things, it will get faster.
And it will also solve the problem of the level incrementing too quickly. This will, in fact, make the game take longer to become as difficult as it was last time. Well, fine.
You missed it already. And there we go. And it is starting to get a little faster.
But again, not going out of control quite as quickly. Let's see how far I can get before I run out of lives.
Now,
and right about there.
We did this just to make a point. Notice how Logan just put a divide by 3 in there. Do you really want to just plug in a number right in the middle of your code? We might want to go back up and make a constant just so we have some sort of control, or speed control.
That would certainly be a good idea, because right now, if later down the road we decide that, we'd like to make this game harder, or we'd like to make it easier, we'd like to be able to play for longer before it becomes uncontrollable, we would have to dig through the source code and find where we had hard-coded in a 3, and even remember that it even was a 3.
Exactly. It's something we don't want you to get into the habit of doing. So now that we've shown it to you, we're stressing that. That was a magic number. Just, to anyone who comes in behind you and takes a look at your code, it's like, why is he dividing by 3? It makes no sense whatsoever. Don't do that. Now, divide by 2s, any programmer can come back in and say, oh, he's taking the width and divided by 2. He's finding the halfway point.
That makes sense.
That makes sense. But plugging a number like 3 in or 6 in, what does that mean? So, again, it's a good idea to come in here and give some sort of descriptive name and tie it in this way.
All right, so let's make a constant integer for difficulty increase, or just maybe even call this difficulty.
Okay,
game
sounds
difficulty. Good. So game difficulty, and we'll set that to 3. And I'm trying to think. The only thing I don't like about that name is if we increase this number, the game actually gets easier.
True.
So game speed increase. I'm trying to think.
Game difficulty control.
I like that. So game difficulty control is currently set to 3. And let's take this now and set this. So let's jump down to reset target and divide by game difficulty control. So right off the bat, you see, what does this have to do with game difficulty?
You got it.
So, and then really, we wouldn't even worry about this place in code. If we said, we would really rather the game get harder more quickly, we could ramp this down or ramp it up.
You got it. Okay, very cool. All right, I'm looking over here at the implementation plan for Canon 1, Logan, and that's everything that we set out to do.
Just noticing one thing, I want to clean one thing up a little bit. Target velocity X and Y don't need to be initialized anymore because they get set when we reset the target. Now that we have gameplay in place, that means we reset that as soon as we begin the game.
Exactly. So go ahead and show them the final working game. So waiting for you to click to begin. And Logan is now actually playing the game. Let's see how good he is. Oh no, come on, you gotta do it, man. Now you've lost 2 lives. What's up with that? And good.
All right, I'll play for a while.
All right, so now he's playing. Let's see, it's speeding up just a little bit. Got his 1 life left, and look at him waiting to fire until it's right on top of him. How funny.
I've played this game a few times. and I eventually lost because my mouse dropped up over the title bar, but there you go.
There you go. So that is Canon in its completed state. Again, following implementation plan for Canon 1, the goal being to create a Windows-based game that is using the event model that comes along with all standard Windows applications, okay? And to just kind of reinforce that, go ahead and close that, Logan, and take them back to the events area. Right now, everything that we're doing, Logan's got those all tied into events. Now, form load is something that we'll continue to use that in the next one.
Right, we will continue to use that because I wanted to start introducing or just getting people used to the idea of initialize, and it almost goes hand in hand with load. You can think of it like that.
But here,
content loading.
The big thing here is the very next method, which is the mouse move method. If you want to go ahead and just move your mouse over that real quick. So here we are, mouse move. This is, again, event driven. So Logan moves his mouse, and that causes this code here to execute. And then we've also got the ability to press the mouse button down. And then with pressing the mouse button down, then we can start the game and fire and all that good stuff. But it's, again, the Windows application is sitting here polling for messages. It's polling for events. And when the event actually occurs, then that code gets executed. And that is not how modern games are designed. Modern games have a game loop.
Or just game engines in general.
Okay, true.
The problem is this kind of decouples the idea of our mouse moving and of the other objects, because the objects update based on a timer interval, whereas the player graphic updates based on however fast your mouse works.
Right. Well, yeah, exactly. Talk about the USB mouse.
Well, I might not be 100% correct on this, but from years ago, my understanding was that...
But with the USB mouse, you get a faster, smoother update.
Right. It used to be something like 125 hertz.
Right.
And if it was indeed that fast, it could even be faster with some of the more modern gaming mice.
Right.
But still, 125 hertz is still faster than the 60 hertz or 60 frames a second we're running our timer at. So we've got two different intervals going on.
So when we switch over to Canon 2, and obviously in the XNA framework game that we're going to create, we basically have a polling that's going to take place to see each time within the 60 times per second, where is the mouse at? What is the state of the mouse? Did he just press the button? So we keep checking that over and over and over. We don't have a polling condition set up here, or a polling framework, if you want to call it that. That's what's going to happen when we move over to more of a game engine. All right?
Right.
So is there anything else you want to add into this?
I just wanted to finish off my thought with load. It wasn't so much initialize. What I was going for is that the idea with load is we're loading a whole lot of graphical content. And then that's the idea that I wanted to continue to use, the idea of loading content when we get into our game engine.
Because obviously in XNA we're going to have the ability to load content.
Right.
All right. So with that brings us to the end of Canon 1. And if you are confused with any of it, I highly recommend you go back and watch over it. Some of the concepts in here have yet to be covered in detail. In other words, we have not yet talked about object orientation at a lower level. You've only seen a glimpse of it when working your way through the Hyperion project. Don't worry, again, an in-depth look of that is coming up in Volume 2 of the XNA Extreme course. And let's see, we're also going to have a video talking about how the distance is going to work and the get center is going to work. So with that, that is going to wrap up this video. Thanks a lot.